Hello everyone, welcome back to another Geostats lecture video. And in this lecture video, I want to actually start to examine our model results. Right? And so if you missed the previous video, I would encourage you to go back and watch that first, because we actually set up two different models. We set up a model with one variable. So we have our dependent variable, which is the sepal length coming out of the iris dataset, regressed against sepal width as one variable. And then we have two variables just to show you that we can chain multiple independent variables together with this plus sign here. So we have two different models, and we're going to actually look and sort of explore and examine what we have. So the first thing that I want to do before we get into examining our results is actually scroll down. So let me bring this code up so you remember how I got here. Question mark stats : LM. This is again the documentation for the linear model, or the LM function. And what we're going to do is we're going to scroll way down, way down, way down, way down to value. So value, this tells you what you're actually getting back. So what we're getting back is an object of class linear model, or LM, and it has all of these different components. And so what we're going to be doing in this video, we're going to use a function called summary that's going to give us some highlights. But what we're going to actually be pulling out are the residuals here, which are the sort of what's left over. So these are the error terms. And then the fitted values here. So these are the what was actually calculated. Okay. So let's go ahead and really quickly go through how we can start to examine our model results. So the first thing we can do is type in SUMMARY, or summary, and you'll see that it is a, actually here, let's do this. So basically, summary is probably one of the most widely what's called overwritten packages, or overwritten functions, in the sense that many libraries and many packages will actually have their own summary function that will overwrite this one. But in this case, right, we're going to use the base summary. And basically what this does is it gives you sort of a high level, as the name implies, summary of the object that you pass into it. So if we pass in object, if we pass in our one underscore var underscore mod, so we're passing in the result of the linear model call. If we run that, you'll see here, if we scroll down here a little bit, that what we've got is a sort of a overview of what we managed to do. So the call, this is just sort of repeating back to us what we did. This is the 5-number summary of the residuals. So again, the residuals are the error. So this is sort of how far off the calculated values were from what we gave it. And then this is probably the more important stuff, is the coefficients. So the sepal.width estimate. So this is that beta coefficient from the regression. So this is how much sepal width influenced sepal length. Okay, so again, this is the beta. And then we have our p-values here to determine whether or not these relationships are significant. Jumping down here, we have the multiple and adjusted R-squareds. So these are the R-squared that we talked about in the conceptual videos, which again are just a measure of how much variation this model is explaining. So sepal width explains just over 50% of the variation in sepal length. So it's not a great model, but it's something. And then we have the p-value down here, which is basically just saying, is this model statistically significant? Which in this case, it definitely is. Okay. So this is sort of, again, the summary. This gives you all of the highlights in terms of model statistics. But we can definitely do a lot more than that. what we can do here is we can pull out some of the things that came in that LM object. Specifically, we can pull out the calculated values by calling 1_var_mod. Right, this is the name of the model, right? It's the variable name. If we hit the $sign key, right, this works just like a data frame. We can pull out all these different components. So again, coefficients, right? These are going to be the coefficients for the intercept and all of the independent variables. Not particularly useful. The fitted values, right? If you remember when we walked through, actually let's do this. Let's go back. Right. So this is the components for the LM object, right? The fitted values. So these are actually what we calculated. Okay. So these are this is what was actually calculated. Okay. So the other thing we can pull out is what I call the resid, and these are going to be the residuals, which again are the so this is the error, right? So for each of the fitted values, this is how far off it was, right? Right here it says residuals, the response minus the fitted value. Okay, so this is the error term. So we can pull that out by doing $sign and then residuals. Okay, so if we run both of these, you'll see that we now have residual here, and we have where's calc? Calc right here. Okay. So now what we can do is we can do two things. The first thing that we can do is we can plot the calculated or fitted, I guess we can call them fitted, values versus the expected values. Okay. I'm just going to use the generic plot function just because it's a little bit easier for me. We're going to have x, and we're going to have y. We want our x value to be our setosa $sign sepal length, and we want our y value to be calc. Okay. So if we plot this, oops, I always do this. We don't want setosa, we want training, because we want to use the same data that we used here. So if we run that, okay, you'll see here that we get a nice graph. So in a perfect world, right, this would be, these would match perfectly. And actually, you know what we can do? We can add an ab line of a equals 0, b equals 1, h 0. I should add, oops, I have to call plot again. Should add a nice one-to-one line. All right, so in a perfect world, these points would all be exactly on this line. But obviously, regressions are not a perfect world. That's why we're using regression. But you can see here that most of these are actually pretty close to the one-to-one line, which is an indication that our model did a pretty good job, at least on the training data. So the next thing that we can do is we can plot the residuals versus expected values. Okay. So in this case, right, we're going to do the exact same thing. We're going to plot the training $sign sepal length, and our y is going to be our resid. So in this case, I'm not going to, actually, you know what? We are going to do this. We're going to do an ab line of v equals 0. Why are you being obnoxious? Oh. Let's call them both at the same time. There we go. All right, so what I've done, so this 0, so this would be in a perfect world, right? We would hopefully all of the residuals would be near 0. But again, regressions aren't a perfect world. And what you're really trying to make sure is that you don't have some sort of pattern in the residuals. And what that means is we would hope that we wouldn't see something that looks like a very sharp line, because that would mean that you're underestimating down here when you're overestimating over here, right? That's what the residuals mean. It's the difference between what was expected and what you got. So you want this to be pretty much flat and preferably close to 0, so that you're not, again, you don't have some sort of underlying bias in your data. And finally, what we can do is we can actually calculate the what is called the mean square error. So what the mean square error does is it's going to tell us the average, it's basically going to give us the average distance of the residuals. Right, and so to do that, we're going to call summary of the one var mod $sigma, and then we're going to square that. Right, so this right here, this is our mean square error. So this is basically the square of the average error. So the higher this is, the worse the worse the model did. So we can see here that it actually did a pretty good job, right? Because that means on average, the squared error is still only 0.5. In this case, it's millimeters, because that's the measure of the length of the sepal. So anyway, hopefully this made sense. And in the next video, we'll talk about how we can take the testing data and go through sort of validating our model. So hopefully this made sense. And as always, please reach out. Thank you.